So now that we know how to work with images and index into different color spaces, we are ready to actually start image processing. So let's read the image of this culvert. As you can see, the name is roadway culvert. So this is actually a section of a roadway culvert built in the mechanical engineering lab. And as you can see, this is the steel culvert. You can see it as a very strong hyperbola. And you can actually see the downward soil erosion patterns here. Of course, if we want to play with the intensity here, we can see more features or hide more features depending on how we work with this color gain, as I mentioned before. But that's not what we're going to do here. Now, the first thing I want to show you is contrast adjustment. Well, most of the time you won't need this, but sometimes it comes very handy, especially in grayscale images, which are easier to interpret sometimes. So first of all, let's have a grayscale image of what we have. Use semicolon because we don't want to see the image matrix. Okay, now the image is here now. Now, let's see. The first command that I want to show you is called IMAdjust. So igray1 is IMAdjust. And we can show igray. Okay, cannot see much difference here. So let's go to the document and explore what this command actually does. So IMAdjust maps intensity values in grayscale image. So the image that we give to this function has to be grayscale to the new value J. By default, it saturates the bottom 1% and the top 1%. So in our case, it doesn't help that much. But it can also give you the threshold. So let's see how the threshold works. Just specify contrast limits. So these values are probably from 0 to 1. You can also use it with an RGB image. It says here. So let's try. This time with, for example, no, it's still not changed that much. Let's give it one value. See if we can give it one maximum threshold. So it does not work. It needs 2 values. How about close to each other? Okay, as we can see, this function probably does not do much for us here. So let's try another filter. First, let's see if it actually operates on the original image. But it doesn't. Oh, I'm sorry. I've been showing you the first image all along. So now we can see the changes probably. Yes, as you can see, this image is changed in this area, right? So let's put these two together. Let's change this to show pair igray1. Well, actually, it's not gray right now. It's still colored, but that's just a name. So igray1, and we want to see more. Okay, as you can see that the image is completely changed in this region. So let's play with the thresholds. First, let's remove the threshold, see what happens. So now this is the mystery that I wanted to solve. First, we read that this function only accepts grayscale image. Then in the example, we see that it actually also accepts RGB image. But how does that work? Here it tells us that specified syntax is only supported for 2D grayscale and additional input argument must be used. So we have to give it the thresholds. So first of all, let's see if we can get the handle. Let's see, that doesn't work. So let's go to the document again. See if we can actually get the thresholds. For grayscale images, the value should be low to high. And again, low, triplet, high RGB, triplet. Okay. So unfortunately, there is no way, as I can see here, so we can actually find out the default thresholds for this. So let's again just keep playing with it until we find something useful. So let's change it to 3, squeeze it in. See, now the image is completely changed. Let's make it even smaller. Now let's go to 8. Okay, so this is pretty cool. You can play with this. If you can find any features that you like, this is the function. Now, let's use the grayscale image now, as it was intended before. Okay, now let's see both of them together, the grayscale image and the adjusted one. There's not much to see, so let's play with the thresholds manually again. Oh, a lot of change. Okay, as you can see that we have done some sort of background removal here. Maybe squeeze the minimum. Okay. How about put this to 8 and we put this to 85. Wow, another dramatic change. So as you can see, you can play with this function. Now, the next thing that we can work with, there's also another one, which is from this manual. So this is the Bible for image processing, guys. It's called, the course is called Image Processing with MATLAB. I suggest everyone to do these 2 courses. First is the MATLAB on-ramp course. And the second is image processing on-ramp. So this one is 2 hours, this one is 2 hours. They're introductory courses and they're very easy. I suggest you definitely do these courses. So let's search them. This is the link you should go to. You can see a lot of courses here. For example, the MATLAB on-ramp course is 2 hours and the MATLAB fundamentals is close to 17 hours. So this one will be just fine. And we have for image and signal processing, the image processing on-ramp is 2 hours and the main one is actually 11 hours. So I strongly suggest you guys do this. It's very easy and interactive. It's not just a boring video. And so you'll definitely learn something from it. All right, let's go back to the manual. See what else we can do. So this is the glacier problem that I was addressing to you before. So the montage is used so we can actually compare two images taken at different times. This is the rescale I was talking about. And there's another one, hist ek. So let's see. I grade 2 equals hist ek I gray. I gray, I grade 2. Okay, now we can see a lot of change. Now, let's take a quick glance again. Document. Transforms the image so that the histogram of the output grayscale has 44 pins. Okay, so let's see. Let's take a look at some of the images. So there are many things we can work with here, but it doesn't have a max or min threshold value. So this is the second command. Now, the third one is this one, adapt hist ek, which, as you can see here, enhances contrast locally, not globally like this one. So let's try it. We can just use this one. I gray 2 equals adapt hist ek I gray. Show pair and I gray 2 montage. Actually looks pretty good. You can see more features when you use this one. You can see the soil erosion pattern more clearly than before. So this is a very interesting figure to use. So as you can see, sometimes very small contrast enhancement can actually help us greatly in visualizing the problem that we have. But remember, generate images without a color map and without a color bar, so that these are also part of the image. So this color bar will also get changed, and sometimes it gets noisy and it's not pretty. So for your project, you can actually only use the image without this part and then process it and add the color bar later to it. You can always do that. So this is the second one. Let's check the document again. You see the document, the original, and the contrast enhanced. So let's try it on the RGB image and see if it works. Okay, it says it has to be two-dimensional. I'll leave it to you to read the document and see, maybe if you read it completely, you can find a way to actually use this on an RGB image. Okay. Now, let's go to the next one. The third thing I want to show you is spatial filtering. Spatial filtering is very good to fix noisy images. For example, one of the syntaxes that I find very useful is actually the Wiener filter. So as you can see that there is a threshold value you have to specify here. So let's try it. So I2 equals Wiener 2, I gray, and MN is optional. So let's see what it will give us. I am show pair, I gray 2, montage. Okay, there's not much. So let's go back to the PDF, see what we can find here. If anything is specified about M and N. Okay, I think it should be a value between 0 and 1 again. So let's play with it and find out. Oh, it's not here. Sorry. I should change it here. Okay, we're missing something. Okay, it should be comma. Size must be integers. So I think we should actually use a neighborhood for this. For example, we can call N1 as a matrix of ones. Let's see if it works now. It says invalid syntax. So Wiener 2, there is a problem here. So let's check the document. Doc Wiener 2. So word is M and N. Filters a grayscale image again using a pixel-wise adaptive. MN specifies the size of the neighborhood used to estimate the local image. The additive noise is assumed to be noise. Okay, for example, let's see how they use that. So there are many other characteristics that you can add, like this Gaussian. I'll leave it to you to read. Okay, so you can actually find a neighborhood here. You don't have to define it before. So for example, 3 to 3. Okay. Now let's make it 15 by 15. Again, we do not see much change, but definitely if you work out with the noise, with the Gaussian noise filter and different values, you might get something out of this. So I've used this before for my project. And in one of the images, this filter was actually really helpful. So this is the last thing in contrast adjustment that I wanted to show.